So you'll see these CIA documents that were approved for release in 2000, and you'll see that this is actually the Scientific Council of the Institute of Physics of the Earth in the USSR, and that they argued for these findings at the geophysical year. It's about light scattering in the high atmosphere, so some properties of atmospheric indicatrices of light scattering by Payaskovskaya, Vasenkiba, the Astrophysics Institute, the Academy of Sciences in Kazakhstan, the USSR. This is done in 1957, but it shows you that even at that time the Russians knew there was a firmament. Determining the coefficient of atmospheric transparency from sky brightness. And you'll see they use several methods to actually determine differences of light in the sky to identify the firmament. So again, by the same author, USSR Geophysics, published in '62, Calculation of Light Dispersion of the Higher Orders. A proof is presented that the light dispersion of the higher orders can be computed from the data obtained in plain direct observations. The brightness of the sky considering all forms of light scattering. Various methods for determining the atmospheric transparency coefficient. And all of these documents as well reference the non-rotating flat Earth, or a flat non-rotating Earth. And I'll put links to them as well. Study of the dispersion of light in the Earth's atmosphere. Joint Council of Institute of Physics of the Earth, the Institute of Physics of the Atmosphere, and Institute of Applied Geophysics. The Academy of Sciences in the USSR. You can't get any higher up, scientifically. In the investigations, 2 instruments designed by V.G. Vasenkov were used. One of these was a visual photometer of the daytime sky, intended for measuring the brightness of the firmament. The other was a photoelectric halo photometer for determining the brightness from near-sun halo and also from the sun on a surface perpendicular to these rays. The dissertation contains a certain formula of the brightness of the sky, taking into consideration only the brightness of the first order, and derived on the assumption of a flat Earth, and giving some conclusions derived on the basis of this formula. For a certain coefficient of transparency of the atmosphere, the brightness of the sky at any point is represented by derivation of 2 functions, of which one is the function of the diffusion of light, and the other is a function of the zenith distances of the sun, and of the observed point of the sky. On changing of the zenith distances of the sun, z, from 90 to 0 degrees, the brightness of the sky on the almucanter of the sun increases first, reaching a maximum for a certain value of z, and then decreases. A method is also proposed of determining the brightness of the clear daylight sky at any point, based on measuring the brightness along the almucanter of the sun, and of 5 or 6 points of the firmament located at various zenith distances. I actually mentioned that they prove that there is a firmament, that they're measuring the light of the firmament, and they know the distance to the firmament, and also that this is done assuming and knowing that the Earth is flat and non-rotating. There you have it, folks. There is a firmament. The Earth does not go on forever. It is not an unending plane. There is a solid firmament in the sky, as was told to us in Holy Scripture by the Most High, by God.